Hello, this is Elena Tovar, and this is my third lab on black holes in orbit. The purpose of this lab was to create coding using GlowScript that would determine the mass of a black hole based on the motion of a star orbiting it. And then for our second part of the lab, we coded again and we simulated the motion of a spaceship that was orbiting a planet and a moon in a figure eight, and we had to avoid crashing into one of the two objects. And then we had to determine what the velocity of the spaceship needed to be in order to do so. So the main ideas was we needed to calculate the force acting on the system. So this included gravity force and the other ones that were included, and use Newton's second law. So here's a preview of the results. For part one, we were looking for the mass of the black hole, which we find here. And for part two, we were looking for the x and y initial speed of the ship in order to complete its orbits. So this is the x and y components velocity. So here's some beginning physics principles, models, and assumptions that we used. We had to assume that all three objects were acting on each other. And then we see in part one that the system is a black hole, surroundings is a star. For part two, the system is a starship, and surroundings are planet and moon. Newton's second law is written down here, which basically just says that the change in momentum over the change in time equals the net force. And then we have to use this in order to find that the parallel component of the net force plus the perpendicular equals the entire net force. And then we use gravitational force, which basically just says that F grav equals the gravity constant times mass 1 and mass 2 over r squared times r hat. So this is the first part of our coding. For part one, again, we were looking for the mass of the black hole. And so we had to change the initial and final momentum to be this. And then we updated all of this in order to calculate the change in momentum over the change in time. And then eventually this led to us finding the magnitude of the black hole, which you can see in the part where it says calculate the mass of the black hole. And then we plugged in our email so it would give us specific data. And this is what we end up. This is the simulation showing that the star is orbiting it, and the arrows are constantly changing in order to show which direction the forces are going. So here's our second part of the coding. Basically, we just need to edit all of the forces acting on each other. So this is the planet to the moon, ship to the moon, planet to the ship, and moon to the ship. And then we found the F net, or the net force on the ship. And then we use this in order to kind of plug and chug the initial velocity of the ship in order to make a full rotation without it crashing for 700 hours in the simulation. This is what it gives us. So some possible errors is that we are only given the forces stated in the problem, which is basically just the gravity force. Also, the simulation does not exactly correlate to reality, so there's probably some error in that. And then we also just had to use trial and error to find the initial velocity. There was nothing really telling us where to begin with this. We were just plugging in values in order to find what would work. So there's probably more specific velocities that could create more of an infinity shape. It's just difficult to do that, as you can see back here. It orbits both objects, but it's not the exact shape that we wanted. This just goes to show that this is a very difficult thing to do in reality. And so our final questions, what does it mean? Fnet equals dp/dt, so these are basically the same thing. For Fnet, you must know each individual force exerting a force on the system. For rate of change of momentum, you only need to know the system's change of velocity. And then what if the imaginary system included a black hole along with the star, planet, and moon? In the computational model, you would need to include the gravitational force of the black hole. The biggest object would have the largest force of gravity, so this basically just means that the black hole would dominate the system due to its mass. Thank you for watching.